Hello everyone, I'm Kama Hamza. I'm a student of Macquarie University pursuing a bachelor's in computer science. We're given an artificial intelligence assignment. I'm here to take it through it. So the assignment, the first question was telling us to discuss the following local search algorithms to relation to artificial intelligence, providing a scenario with each of the algorithms. We had hill climbing, simulated annealing, and genetic algorithm. So I'll start with hill climbing algorithm. Hill climbing algorithm is an algorithm of local search that moves upwards continuously so as to realize the peak of the mountain or the best solution to the problem. It stops when it reaches a peak value where no neighbor has a higher value. So as we can see here in hill climbing algorithm, we have a shoulder global maximum, local maximum, current state, and a flat local maximum. So in the different regions in the state space landscape, we have a local maximum, which is a state which is better than its neighbor state, but there's also another state which is better than it. Then the global maximum is the best possible state of space in the state space graph. And then the current state is the state in the landscape diagram where the agent is currently present. Flat local maximum is a flat space in the landscape where all the neighbor states of current states have the same value. Then the shoulder is a plateau region which has an uphill ridge. Again, this takes us to the next algorithm, which is simulated annealing. And simulated annealing is a random search method in which new solutions generated according to a sequence of probability distributions, Iggy-Boltzmann distribution. Then we have genetic algorithm, which is a heuristic search algorithm that belongs to the larger part of evolutionary algorithms. Genetic algorithms are based on the ideas of natural selection and genetics. So this takes us to our next question, which is discuss how you would improve the usability of all those strategies used using responsible AI and explainable AI. So a way of improving the usability of general genetic algorithm, we diversify the initial population. We include diversity, where we start with a more diverse initial population to explore the solution space more thoroughly. Then we also use randomness. We introduce randomness in the initialization process of, or use techniques like Latin hypercube sampling. Then in simulated annealing algorithm, the way to improve usability, we reduce the amount of wasted on non-productive search. This is a way of increasing the usability because it enhances high potential impact where it's prioritized, and then the non-productive search is reduced. Then in hill climbing algorithm, the effective strategy to improve usability is doing random restarts. As we could see, there are very many regions like the shoulders whereby the agent can get stuck there. But if we introduce a random restart, then it gives us chance to move to a different area. For example, if our agent is in the shoulder, there is, if we do a random restart, can it start at any other slope, which gives us better chance of finding the global maximum. And then this takes us to question 2, which is discuss define adversarial search, and with examples discuss the minimax and expect minimax. And then with an example, discuss the alpha beta pruning technique and what its main purpose in adversarial search. So adversarial search is a search type where the problem which arises when we try to plan ahead of the world and other agents are planning against us. So adversarial search can be used in society in the following scenarios, which is decision making under uncertainty, which helps AI systems to make decisions under uncertainty by evaluating possible actions of opponents by using tree searches and tree graphs. They're also used to develop in chess and checkers and tic-tac-toe, the graph trees of these games, which are the most popular games that can be solved using adversarial search. This takes us to minimax algorithm. So minimax algorithm, there's always a maximizer and a minimizer at both stages. As one does maximizes, is another who is minimizing. So the minimax algorithm operates under the assumption that both players in a game are rational and will make the best possible moves toward their objectives. The primary goal of the algorithm is to minimize the possible loss for a worst case scenario. And here is how it works. It has a tree structure. The algorithm models the game as a tree. Each node represents a game state and the edges represent possible moves. Then there's maximizing and minimizing layers, as I talked about it earlier. The tree is explored layer by layer. One player maximizes and the other opponent aims to minimize it. So then the third is we do a recursive depth first search. A depth first search is we go checking what is on in the most left. So we check A, B, D, and H. So then the fourth step is optimal strategy. At the root, the score represents the best achievable outcome with perfect play from both sides. This score dictates the maximizer's optimal move under the assumption that the minimizer is also playing optimally. Then this takes us to expert minimax algorithm. So expert minimax algorithm is a variation of minimax algorithm, but with chance. So here, artificial intelligence systems play two-player zero-sum games such as backgammon, in which the outcome depends on a player's skill and chance elements as dice rolls. So in addition to min and max nodes, we add another variant, which is chance. So then alpha beta pruning is an optimization applied on the minimax algorithm in the domain of adversarial search. The algorithm aims at reducing the number of nodes in the game tree explored by a minimax player. So in alpha beta pruning, we have alpha, which is the best score for the maximizer, and beta, which is the best score for the minimizer. So as you can see here, we have the graph tree of a game, and then we have we have this as our value. So we take this, if this is max and min, so we keep on checking what is best. So as we see here, we took 3 up to the maximum, to the highest node, and then we came back checking depth first to while minimizing or maximizing according to what we're supposed to do. So as we can see here, we reached a point whereby we were minimizing, and then these 3 changed to a 2. But then on this changing to a 2, we did need to check all these values since they're already smaller than 2. So we pruned them off. This is what this image is showing. Since our alpha was 3, and then when we got a value below 3, which is 2, and it moved upwards, these other values, since they were bigger than 2, we just pruned them. Then this takes us to our third question, which is discuss the concept of adversarial machine learning and describe how adversarial machine learning is related to adversarial search. So adversarial machine learning is a process of extracting information about the behavior and characteristics of an ML system and learning how to manipulate the inputs into an ML system in order to a preferred outcome. So adversarial machine learning and adversarial search are in relation to the fact that both contain some form of competitors, though in different applications. So as you can see here in this image, adversarial machine learning, we manipulate what the model knows or the agent, and then we make it misclassify it. So we make sure it misclassifies the dog image as cat due to another adversarial attack. This leads to the end of my presentation, and these are my references. Thank you for watching.